Mr. Ramana Reddy is the Vice Chairman and Managing Director of New and Renewable Energy Development Corporation of Andhra Pradesh Limited. He is an IRPS officer and he is currently serving as VC and MD for the past 2.5 years and also as a Chief Executive Officer of APS, PCL, and APGCL. Prior to joining the NREDCAP, New and Renewable Energy Development Corporation of AP, NREDCAP, Mr. Reddy was working as Director Watershed Development Program in Government of Andhra Pradesh. Mr. Reddy has completed MSc in Agriculture from Haryana Agricultural University, then selected for civil services in 2007. Since taking over as MD and RedCap, Mr. Reddy has devised several renewable energy programs such as renewable energy export policy, hydro storage pumping, promotion of mobility ecosystem in AP, etc. So a very warm welcome to you, Mr. Ramana Reddy.
Thank you. Thank you. Yeah, thank you, Mr. Misraji, for organizing this wonderful summit. So, in fact, it is a great opportunity for us to keep interacting with many leaders who have already pioneered in the technology and in running the major PSUs. Just now, our Mr. George, our CMD HLL, has spoken a lot of things about the developments being taken up under the HLL Lifecare Limited. And it gives us a very immense pleasure to be here and to participate in the summit. So, in fact, this New and Renewable Energy Development Corporation is working in the energy area, especially promotion of renewable energy. It is one of the PSU and government of Andhra Pradesh. So, we are working closely with MNRE Ministry and also NTPC, SECI, and ESL. So, because these are the agencies involved in promotion of renewable energy programs in Andhra Pradesh. So, as such, this under NETCAP organization, so we have more than 4,200 megawatt of wind energy established in Andhra and also nearly 4,000 megawatt of solar energy. So, all put together, more than 8,250 megawatt of renewable energy already installed. So, in addition to this, another 10,000 megawatt of renewable energy will be adding shortly in a couple of years. It is in planning stage. So, these are the major chunk of renewable energy. Apart from waste to energy power plants and mini hydel power plants and other biomass based power plants. So this is the energy portfolio in terms of renewable energy. So with this, we are able to achieve this renewable power purchase obligation. We have crossed even the beyond that whatever the target fixed by the government of India. So as such, if you take in terms of energy installed capacity, it is more than 45% of energy installed capacity. If you take Andhra Pradesh energy mix. So this gives a good indication that Andhra is progressing and pioneering in terms of renewable energy. So that in terms of application of the technology in terms of renewable energy promotion, so for wind energy, so we need to have a technological intervention to assess the wind energy potential in nook and corner of the Andhra Pradesh. So for that, we have to establish energy that means METMAST, wind energy potential assessment METMAST. So here we are using a lot of digital technology solutions to daily assessment, data procurement assessment, and also it's a calculation of the exact potential of the energy available in that area. So in addition to this, in solar energy also we are using a lot of data from satellite and ISRO and other digital applications are being used for promotion of renewable energy. As such, renewable energy is a key input for any other industrial production process. As such, supplying the energy at a cheaper cost becomes a challenge because renewable energy is variable in nature. So we have to use as and when it is available. So otherwise, globally, if you take, there are no energy storage solutions available except in a few countries where already they have established pumped hydro storage power plants. So there we are able to store a large scale of energy. Otherwise, in India, as such, we don't have much energy plants where we can store energy. So battery is the one sector which is upcoming now to store renewable energy whenever it is available in excess quantity and use it other times where energy is not, renewable energy is not available. Especially if you take solar energy is available in daytime in excess quantity. So we have to use this energy to conveniently use it either evening time or early morning time. So here we need kind of storage solutions. So now globally there is a emerging trend to store renewable energy and use it 24/7. So you want to convert a variable renewable energy into firm energy. So to convert this variable energy into firm energy and to use it 24/7, we need some kind of energy storage solutions. Now globally the emerging technologies are hydrogen energy, now is one energy, and a different kind of battery chemistries are emerging. So there are a lot of digital technological solutions, artificial intelligence applications are being used to use it 24/7 and to monitor the energy level, different kind of parameters of energy. So that is one area. So where under the NREDCap, so we have taken up a big survey to identify the potential sites uh, to store the energy, renewable energy, like pumped hydro storage. So out of the 20 big survey, potential survey we have taken up, we have selected 7 locations and we are going ahead in preparation of the DPRs. So with this, we will be storing around 6,400 megawatt of energy. Renewable energy we can store there. Whenever the daytime excess solar power is available, we can pump the water from lower reservoir to upper reservoir. We can store the water. When renewable energy, that is solar energy, goes to zero, then evening time or early morning time, we can generate by releasing the water like normal idle energy generation. So this is the one initiative under the NEDCAP we have taken up, and the DPR completion will be done by end of 22 December. From then, it will take another 3 to 4 years to complete the construction of these energy power plants. So this is the one area, energy storage area, where we are working. In addition to this energy already established, this wind and solar is already established energy generation practice. In addition to this, we are making efforts to identify the wave energy potential, because Andhra Pradesh is having more than 970 kilometers of coastline. So far, we have not able to tap the potential of ocean energy. So not only in Andhra, in entire India, if you take, there is no single ocean energy tapping technology available. So we are in discussion with European countries like Portugal and Germany, where they have already established some experimental wave energy power plants and also ocean-based, current-based energy power plants. We are in discussion with them to establish a pilot power plant which is running on wave energy. So in addition to this, there is another practice where some of the countries have already established this tidal-based energy power plants. So this is another area where we are working to tap the energy, tidal energy and ocean currents energy and wave energy. These are the 3 areas. So by this way, so we are able to supply the renewable energy beyond 50% of the capacity, so that our aim of running for zero economy, zero carbon emission. Now, globally, every country is talking about zero carbon emission economy. So some of the countries have fixed the target of achieving this zero carbon emission economy by 2040, 2040 by 2050. Even so, India is also running towards achieving zero carbon emission economy. So for that, the key component will be going for more and more usage of renewable energy. So under these aspects, so these are some of the areas where we are working. So in addition to this, now emerging area is everybody is aware of it, and the promotion of e-mobility. And everybody is talking about e-mobility and how to supply energy to the different segments of e-mobility vehicles, 2-wheelers, 3-wheelers, long journey vehicles, trucks. So in this area, we are working especially to promote 2-wheelers and 3-wheelers. Especially 3-wheeler segment, especially take auto and luggage autos. These are the major pollution causing segment of the vehicles. So we are working on these areas by use of different digital application solutions like battery swapping stations and energy management systems, and also digital interaction with by use of GPS coordinates. So we are divided one program of supplying electric 2-wheelers to government employees. So in collaboration with CESL, is a subsidiary of ESL. So we will be launching the program in the next month, first week. So where we have targeted to supply at least 1 lakh electric 2-wheelers to different segments of government employees on EMI basis. So for that, major challenges for 2-wheelers and also 3-wheelers, establishment of charging stations and managing the charging stations. So and energy supply. So for this, we are working to establish even these battery swapping stations in 3 by 3 kilometer grid in cities, and also normal charging stations for major vehicles, trucks and buses along the national highways. we are establishing at every 25 kilometers one charging station. So energy supply is the major problem in terms of mobility. So in addition to these traditional technologies, where NMC, LTO, and other chemistry batteries, so we are entering an MOU with startups who are working in hydrogen fuel cells and other kind of advanced technologies to supply energy. So supplying the energy is the key factor in terms of promotion of e-mobility. So obviously, so we have to see the short-term goals and also long-term goals. In terms of long-term goals and achieving larger mileage vehicles, so everybody is talking about hydrogen fuel cells is the one area where we can achieve the long-term transportation vehicles, both trucks as well as passenger vehicles. And short-term vehicles like two-wheeler, three-wheelers, with existing technology itself, we can manage. So for that, we have devised on a mobile application to take up a survey and to digitally interact with consumers, and also to interact with the various charging stations and swapping stations. So the consumer can book a prior appointment for the charging his vehicle before reaching that charging point. So he need not wait there. So with the GPS interaction, so we have developed an app. So you can open the app, you can book a slot in that for charging his vehicle. So there are a lot of areas where we are using this digital applications, and also now the low-speed vehicles where there is no need of registration with the transport department. So theft is becoming one of the problem. Once the vehicle is stolen by somebody, then there is no point. You cannot trace the vehicle. So in this area, we are using GPS fencing, geo fencing kind of technology and GPS coordinates. So once the GPS technology is available, then we can trace out the vehicle, and even battery also is enabled with the GPS technology. So these are some of the areas where we are using the geo technologies and digital technologies in promotion of e-mobility. So in addition to this, now upcoming area where we are working is production of green hydrogen. So recently, Government of India has started a hydrogen mission, national hydrogen mission. So now future fuel will be hydrogen. So now, as of now, we are dependent on import of more than 80% of our energy getting imported from other countries. So instead of that, why can't we generate our green hydrogen by using our plenty of renewable energy resources available in India? So this is the one area where we are working now. So once this becomes realized, and then technology is we are able to get the technology, proper technology, then we will be starting running the vehicles on fuel cell based technology also. So these are some of the areas where Netcap is working, and we are happy to be part of this kind of summits and keep interacting with so many experts, and learning from other expertise. So now I would like to listen from other key eminent speakers about many more technologies and applications. Thank you.
Thank you. That was Mr. Ramana Reddy, Vice Chairman and MD of New and Renewable Energy Development Corporation of Andhra Pradesh.